All right, well, continuing on here, let me get a share screen going. So the idea behind the shader graph is that it's a graphical approach to making shaders. It's a bunch of modules that we connect with wires, and it's a different way of programming. We can start off by making a shader, create shader PBR, that's physics-based rendering graph. Opens a basic template for a shader graph. You'll see other options. There's the subgraph, which is kind of like a function with inputs and outputs that you can write yourself and then use as a tool in your own shader graph. And there's also the unlit graph, which is a simplified one that only has a color and an alpha channel. One of the key components of a shader graph, and I have one over here, I've made this. This is the simplest shader graph, and I opened its shader editor here, which I've docked over here so that I can look at things. And this has three pieces. There's kind of the arena in which we build our modules. There's the blackboard, which is the inputs to our shader. And finally, there's a preview that shows you what your texture looks like. And this, of course, is a rotatable, movable object that you can play with. So in this one, I have one texture, a texture 2D that's named albedo. This shows on the blackboard here. I've added it, given it a name, put in a default texture, and said that it's exposed. So it now shows on my object, just like any of the materials that we're familiar with. It's got a slot for the albedo, and that's the only input. So here I've put a white texture in it. In this other one, using the same shader, I've put in the bricks, and so this is the default, but this can be overridden. So that's so we take that property and you can kind of drag and drop it into the scene, and you get a copy of that input. I've already got one in here, so I'm just going to go ahead and delete that one. I'd already done that. And this I'm connecting to a sample texture 2D module. And there's a slot here for textures. The colors mean different things. And this is a fairly smart system. It won't let you connect something that it's not allowed to connect. And the main window I just showed you that has the interactable objects. So to make one of these nodes, we can pull down the Create Node menu. And there also are notes for documenting your code. But we create a node, and it opens up this menu of all the different nodes that are there. So if I want the sample texture 2D, I can type sample in here, and it starts to show me all of the different modules that begin with the with sample. And I can pick this texture 2D, and there it is right there. So the next step is to connect it, to connect our texture to the sample texture 2D, and then finally to connect the RGB output of that sampler to the albedo of the master. The master is the thing that is going to generate the picture. And note that it has options for outputting each of the 4 channels of a sample texture, the red, green, blue, and alpha. But here I'm just taking all 4 of them and putting into the albedo. And that's all there is to it. That's a complete shader that does this. It makes these four, or these two little cubes, the white one and the brick one. So nothing terribly spectacular here. These are very, very simple shaders that don't do much. But it is lit and shaded and has all that stuff. One thing about these shaders, if you're editing one like this, and I've moved something around or changed some connection, you must remember to save the asset. Otherwise, you lose all your changes when you drop out of this. That was pretty simple. Let's do something more interesting. One interesting modification is to animate a texture. Another thing that we might do is to modify the position of the material surface, make it appear to wiggle. And of course, another is to do transparency with cutouts and have the cutouts be rimmed by a glowing self-illuminated color, all kinds of fancy stuff that we might try and do. So animating texture, here's a very simple animated texture. I've got a couple of textures here on different objects. I'm using the same shader for all of these. The shader is a scrolling material that has an albedo, a normal map, a direction that it's going to scroll, a speed, and a tiling for the texture so that I can set different values for different objects with the same shader. And this just works exactly as you would expect. The textures are animated. They roll around their UV axis. And so we've got stuff happening in here with our animated textures. And each one of these can have a different direction, can have a different speed, can have a different tiling. All of that is handled by the shader. So in the shader, we want to be able to set a direction and a speed. The direction is a vector 2, our UV coordinates, or two-dimensional coordinates. The speed can be a float, which in ShaderGraph parlance is a vector 1. And both of these are exposed in the material inspector. We also need an albedo for what the pattern is that what texture we're going to put on our object. And since it's easy, I'm also adding a normal texture for bump mapping. And since we're fooling with the UVs, I've also added this tile scaling. This could be either a vector 1 if you were going to scale uniformly in both directions, or if you wanted to, you could use a vector 2 if you wanted to be able to scale the UV tiling in 2 directions. You could make it bigger in one dimension than the other. So the blackboard, when we end up setting it all up, has these different properties. I've collapsed them so that they don't take up so much space, but we have an albedo. The normal is a texture. These are both textures. We have a direction that's a vector 2, a speed that is a vector 1, and a tile scaling that's a vector 1. And by clicking and dragging each of these into the ShaderGraph, we can begin to hook things up. Since we're moving things, we're going to use the time node. At first, I had trouble finding these things. They were all buried in these cascading menu pull downs. I found that you could look them up in the documentation that's linked through the package manager. I found that time was under input basic, and at this point I noticed that there was a search window. So if you and even vaguely know the name, you can find it by search. So that made it life a lot easier. I take that time. Here's the time node. It has a number of outputs, one of which is the time. And I'm multiplying that by the speed. And this is a multiply node. It has two inputs. It multiplies them together and it outputs them. So the time.time in our thinking way gets multiplied by this speed, and then that's passed on to someplace else to do things. A lot of these nodes have this kind of window here that shows what the texture looks like at this point. Since I haven't got a texture in this one, nothing's happening with it. And it's collapsible by clicking up on the upper right-hand corner. Notice the time node also has a sine of time, a cosine of time. It has the delta time, that's time.delta time, and it has the time.smooth delta time. So all of these are accessible in our shader graph. With a second multiply node, I'm going to scale that direction. That's a vector 2 by the output of that first multiply, that multiplied time times speed, and I'm going to take that and put it into slot B of this multiply. And the direction, remember, is a vector 2. So this multiply is overloaded to take care of the fact that one is a vector 2 and the other is a vector 1. And so the output of that is going to be a vector 2. Note, here's the multiply routine or module node collapsed down so that it doesn't show that spurious white square. And you can do that with any of these nodes to make all of this much more compact. The output of that multiply then goes to the tiling and offset node. Tiling and offset node, it takes the tile scaling property, that vector 1, and as the tiling 2, and the output, which is a vector 2 of my scaling of my the multiply here, and I'm going to pass that on then to the albedo, pass the output of that to the albedo. I also had the normal texture, the bump map as an input. I pass it to a sample texture 2D, and I pass it directly on to the normal. I'm sorry, the tiling and output goes to a sample texture 2D, as well as to the sample texture 2D that's taking in the normal map. This way, the albedo and the normal map are both going to scroll at the same rate. This is the UV of both these textures, and they both then go to the appropriate slot. The texture goes to the albedo and the normal map goes to the normal. And we have our scrolling texture that, as I showed you, looks like this. The different scrolling. So pretty cool. Let me just show you that shader. Scrolling shader graph. The A key kind of focuses things. So here's that whole shader all set up and ready to go. If I changed anything, be sure and save it. Okay, so that's our first kind of simple but interesting shader that does something. It animates a texture. I'm going to pause here and I'll come back for the next trick, which is deforming an object. This is going to look like this. we have an object that is deforming. So I'll come back in a minute and set that up. I'll stop sharing and I'll end the recording and see you in class. Bye.